Welcome back. Today we're going to talk about compound inequalities. Okay, a compound inequality is an inequality that has an upper and a lower bound. So for instance, if x is sandwiched in between, so this says that x is greater than or equal to 6, and it also has an upper bound of 8. So x can be strictly less than 8 and greater than or equal to 6. Okay, so x can be an integer value like 7. It could also be 6. It could be a non-integer value like 7.999, right? Because that number is less than 8. So there could be a lot of things. To indicate all of the possible solutions here, we can graph it. Now when we graph it, let's put 6 and 8 on the number line here. We want to translate these inequality symbols into closed and open circles. So here we have a closed circle at 6 and an open circle at 8, indicating one's greater than or equal to and one's strictly less than, and we shade in between. So that's how we graph it. Now when we use the interval notation, since it has an upper and a lower bound, we're not going to use the infinity symbol anymore like we did with the simple inequalities. We are going to have a lower bound that's an integer, 6. I use the square brackets because it's a closed circle or it's an inequality here. And the upper bound is 8, and I'm going to use an open circle to indicate that I can't include the value of 8. Okay, when I solve a compound inequality, what you're doing is so recall that, so let's just review what this is saying here. This is saying that a number minus 5 is going to be less than or equal to 0, but greater than -7. So we're looking for what we can put in for x so that when we subtract 5, it's between 0 and -7, essentially. Okay, so when we solve this to try to get x by itself, we actually have to pay attention to these bounds. Okay, so right now the expression is sitting between, this expression right here is sitting between -7 and 0, right? With an open circle here and a closed circle here. This is where this expression is. So when we add 5 to both sides, we're going to have to add 5 to everything, because essentially what you're doing is, let's say that this is all the possible values that the expression can be, right? By the expression I say x minus 5, what you're essentially doing is saying that you're shifting the entire thing up by 5, right? So this now is between, so if I add 5 here, it would be -2 is less than, this would cancel here, x is less than or equal to 5. So if x minus 5 is between -7 and 0, then x itself must be between -2 and 5. So you see how I did that? If the original expression lies here, then when you add 5 to everything, it shifts the entire thing up by, everything shifts up by 5, the lower bound and the upper bound. So here I can graph the solution set. I just actually did it up there. So let's put, -2 and 5 on a graph here. We want to put an open circle at -2 and a closed circle at -5 and shade in between. Now we're going to have a rounded bracket at -2, comma, the upper bound is always on the right hand side, remember that, and a closed bracket at 5 because it's a closed circle, or a square bracket at 5 because it's a closed circle. Okay, let's try another one here. Now when I start to solve, I want to remember that I'm subtracting 8 from every part of the upper, the lower, and the middle parts. Okay, this is -14 is less than, here I have -2x is less than or equal to -12. So here this is saying that -2x must be between -14 and -12. Okay. Now, something interesting happens when you divide everything by -2, and this is what you've seen before. We are going to have to flip all of the inequalities around. So if -2x sits between -14 and -12, then we know that x has to be between, let's say this is 7 here, and this is 6. So we're going to flip this inequality to be like this. Okay. So think about this. If x is between 7 and 6, essentially, okay, so let's say it's let's say it's 6 because it's allowed to be equal to 6. Then that means 6 times -2 is going to sit between -14 and -12. Okay, when you flip them around, the upper bound becomes on the left and the lower bound becomes on the right. So you actually have to translate it so the lower bound ends up being on the left-hand side here, like this. and the upper bound ends up being on the right hand side. So these two are equivalent inequalities. So once, if you flip it around, you're going to have to translate the inequality so that it actually ends up being a little bit easier for you to graph. So here, when you graph it, you have, you want to put 6 and 7 on the number line, closed circle at 6, open circle at 7, and shading in between. And here you have a square bracket at 6, and you have a closed circle at 7. Okay, so I know this might be a little confusing, but you just have to be mindful that there are 3 parts to a compound inequality that you have to attend to. When you subtract 8, you have to actually do it to all parts. And if you end up dividing by a negative number, now it doesn't, if it's a positive number, then you don't flip the symbols around. It's only if it's a negative number that you have to pay attention to flipping the symbols around. Now, if you do end up flipping the symbols around, you have to translate the inequalities so that the left-hand side, it becomes your lower bound, and the right-hand side is your upper bound. That way, it's consistent. So all the way down here, it's consistent 6, 6, 6, 7, 7, 7. So it's consistent like that. Okay? Now, the review of the symbols. So the inequality can be, this is supposed to be shaded here. So if it's between 2 open circles, the inequality is a less than and a less than symbol, and the interval notation is going to be 2 rounded brackets like that. Okay. So let's actually put some values in here. Let's say that this is A and B. Let's say that this is A and B, and X is between these numbers. Okay, so that we would say that A is the lower bound and B is the upper bound. Okay, if it's 2 closed circles, this is A and B here, then what we're looking at is X is less than or equal to B, but greater than or equal to A, and you can use square brackets for both parts here. If one is open, then again, if this is A and B, then your lower bound is going to be a strict inequality, and your upper bound is going to not be a strict inequality. And we have an open circle here and a rounded bracket here and a square bracket here. And finally, if this is A and B like this, then X is going to be greater than or equal to A and less than B. And so you have a square bracket here and a rounded bracket here. Okay, these are all the combinations of what you would see with a compound inequality. And that is the end of the lesson for today. So today you learned how to solve compound inequalities by using inverse operations on all 3 of the parts, the middle, the lower bound, and the upper bound. And you saw how to represent compound, oh, by the way, these should be shaded in between. You saw how to represent compound inequalities by graphing them and representing with them the solutions with interval notations, right? Remember that interval notations mean that any number in this range of numbers can be substituted into the inequality to be a solution to the inequality. And that's the end of the lesson for today.